So today we're going to look at solving polynomials graphically. So first thing we need to know is polynomial inequality, of course, results when we have a polynomial equation, and instead of an equal sign here, we have an inequality symbol, either a greater than 0 or a less than 0. So what we're asking in this question is, when is the polynomial, for what x values, is this polynomial, x cubed minus 2x squared plus 1, greater than 0? When are the y values of this polynomial greater than 0? The difference here compared to our equations that we're solving is that the answer will be an interval, okay, or a range of values, and we're going to look at a few different methods for solving. Obviously, we could graph the polynomial function using a tool and then be able to state the intervals where the function is greater than 0 or less than 0, in other words, when the function is positive or negative. I don't think I need to let you know how to do that. Today, we're going to look at specifically doing it graphically, and then tomorrow we'll have a look at how to do it algebraically. Okay, so sorry, we're going to graph by hand today. Okay, so to solve a polynomial by graphing, obviously the first thing we need to do is we need to look at the left-hand side of this, let p of x be that, and we're going to need to graph the polynomial. So let's start off. We know that we're going to let p of x be the polynomial, and we're going to go through our usual work of factoring this. Looks like 2 is going to work. So p at 2 is going to equal 0. Then we know that x minus 2 is a factor. And we'll set up our synthetic division. We have our minus 2 here. 1, minus 2, minus 9, and 18. Our 1, negative 2, we're going to get 0, 0, negative 9, and of course 18, and that gives us a remainder of 0. So what do we have so far then? We have x minus 2, and then we have x squared minus 9, and we are actually looking for when is that less than 0, when is that negative. Okay, we can factor it a bit further. And now we know that to sketch this, we need the x-intercepts. So we know that the x-intercepts are x equals 2, 3, and negative 3. And so let's make a quick sketch of that. We have, that's, let's say, our 2. That's our 3. That's our negative 3. And we know the leading coefficient is positive and it's cubic, so we know it's going to look like this. And now looking at the graph, we can state our conclusion. Okay, so just keep that graph in view there. And then we know, therefore, then, that our original polynomial, x cubed minus 2x squared minus 9x plus 18 is less than 0 when, what do we have here? X is less than negative 3, and between 2 and 3, this section right here. So let's just write that in. When x is less than negative 3, or between 2 and 3. Okay. So let's try another one just to make sure we have all of the concepts down. So the first thing you, of course, notice about this one is we do have to move everything over to one side, and this one's actually asking us when it's going to be greater than or equal to 0, so we'll have to include our equal sign. So first let's look at what this becomes. The question really then is, when is x cubed plus 3x squared minus 5x minus 7 greater than or equal to 0. So same thing, we're going to use the factor theorem to go ahead and factor this. Negative 1 is going to work. So we have x plus 1 is a factor. Sorry, that's a 1. Negative 7. Okay, so this is what we're solving. We have our x plus 1. We have our x squared plus 2x minus 7. When is that greater than or equal to 0? Okay, so let's find our x-intercepts. Move that up a little bit. We have one x-intercept here of x equals negative 1. And then over here, we're going to have negative 2. Doesn't look like it factors. Plus or minus the square root of 4. And then it becomes plus 28, so 32, all over 2. And if we just approximate those as decimals, looks like we get something about 1.8 if I punch that in, and something like negative 3.8. So we have 3 x-intercepts. Of course, if we weren't graphing, we would do the exact values of those radicals, but since we're graphing, it's okay to go to decimals. So I'm going to draw a quick little sketch here. I think I'll just continue working down here. Okay, so if we're drawing a quick little sketch, then we would have an x-intercept at negative 1, we would have an x-intercept at negative 3.8, and we would have an x-intercept at something like 1.8. Okay, and again, this was a cubic polynomial with a positive leading coefficient, so it would look something like this. Okay, and so our therefore statement, then therefore we have x cubed plus 3x squared minus 5x minus 7 is greater than or equal to 0 when? Now we do need our exact value for our conclusion, so let's go ahead and make sure we have our exact value of our radicals. Okay, so just this can be written as negative 2 plus or minus, it can be 16 times 2, so 4 root 2 over 2, and that of course simplifies that into negative 1 plus or minus 2 root 2, right? That's the way to write that radical exact. So it's because you do want to do that when you're stating your conclusion. So the places where this function is greater than or equal to 0 is going to be over here. And this time we're going to include the zeros, and when it's greater than negative 1 plus 2 root 2. Okay, so when x is greater than or equal to negative 1 plus 2 root 2, or from negative 1 minus 2 root 2 is less than or equal to x is less than or equal to negative 1. Okay, so we're going to practice these in class just so that you can see all the different examples. Again, you're still using a lot of factor theorem and getting faster and faster at building those skills. See you in class.